This is homework 13 for 11. We want to find the unit tangent vector, the normal, the principal unit normal vector, and the curvature. So to find the unit tangent vector t, we need to find r prime and the magnitude of r prime, because t is equal to r prime divided by its magnitude. So we have to do a product rule to find the derivative of the first component of RT. We have 8 ET, cosine of t. We find derivative of ET, which is just ET. There's a coefficient of 8. Derivative of cosine is negative sine of t. Once we have found the derivatives, then we multiply these two plus these two. The order doesn't matter. We could go this way first plus this way second. So if I multiply, I get 8 ET times cosine of t. Positive times negative is negative 8 ET sine of t. Since they both have 8 ET, I could just factor that. And that would be derivative of this piece. I also have to find derivative of this component. So instead of sine, instead of cosine, I put sine. And derivative of 8 ET again is 8 ET. But derivative of sine is just cosine. Again, I multiply these two, put a plus sign, and then multiply this. Again, I can factor 8 ET from both of them. And that's what's going to be the derivative of the j component, or rather the y component. Derivative of 2 is 0, so we found r prime. Next, I am going to find the magnitude of r prime. So to find the magnitude of r prime, we are going to square the x component of the r prime vector. So we get 8 to the power 2 et to the power 2. This is a factor, this is a factor, and this is a factor. And then cosine t minus sine t to the power 2. Plus, now I have to raise this to the power 2. So I raise 8 to the power 2. Et to the power 2, and sine t plus cosine t to the power 2. And I don't have the I and j anymore. 8 squared is 64. Et to the power 2 is et, e to the power 2t. Cosine t minus sine t to the power 2 gives us cosine squared minus, because we have a minus, we multiply these 2 by cosine by sine. This is our a times b term times 2. Plus, we raise sine to the power 2, which is positive sine square of t. I also have to raise 8 to the power 2. These are all under the radical. So this is, just goes and still. I just didn't have room, so I have 64. This continuation goes here. 64 e2 to the power t. If I raise that to the power 2, I get sine squared plus 2 times sine times cosine. The order doesn't matter, so I put cosine first, sine second, plus cosine squared. So now that I have two terms, both terms have this in common. So I'm just going to factor that from the two terms that I have. This is one term here. This is one term, plus this is the other term. And they both have that, they both have 64 e to the power 2t in common. So I'm just going to factor that, factor 64 e to the power 2t from both terms. So when I factor it from the first term, from this one, I'm left with these guys. So I'm left with cosine squared minus 2 cosine sine plus sine squared. When I factor it from this term here, when I factor that, I'm left with that, which is plus sine squared plus 2 cosine times sine plus cosine squared of t. Also, in algebra, you could have distributed this by every single term and then distributed this one by every single term and collect a like term or add all the terms. I just kept that 64 e to the power 2t since it's a common factor outside, but I basically did the same thing. I just wrote all these guys and all these guys inside one parenthesis. We know cosine squared plus sine squared is 1. I have another sine squared plus cosine squared. That also gives me another 1. So that plus that is 1 under the radical. Cosine squared plus sine squared, that's also 1. Minus 2 cosine plus 2 cosine cancel each other. So I just get a square root of 64 e to the power 2t times 2. Now, if I want to simplify this, instead of multiplying 2 by 64, I just look for the square root of 64, which is 8. I find the square root of this factor, which is the square root of e to the power 2t, which is, if I write it in this notation, instead of having a radical, I'm just going to write it as a fractional exponent. So I have a 2t divided by 2. These 2's cancel each other. I get e to the power t. So square root of e squared t is et, e to the power t, and then a square root of 2. Because I don't know what the square root of 2 is. We just leave it as is. So this is, the whole thing is the magnitude. I have to divide this magnitude by this component and that component. So t, which is the unit tangent vector, is going to be 8 et cosine t minus sine ti. I divide it by 8 et square root of 2 plus 8 et cosine t minus sine t j divided by 8 et square root of 2. So these are canceling each other. So the unit tangent vector is, I could also write that, 1 over square root of 2 cosine t minus sine ti plus 1 over square root of 2 cosine t minus sine t j. Oh, the other parenthesis is plus sign. So now that we have t, we could find n. To find n, we have to find t prime with respect to t divided by its magnitude. So we have to find derivative of this guy. So I have to find derivative of the x component and the y component. So t prime is equal to Derivative of this, I just leave the coefficient, and then I find derivative of cosine, which is negative sine. Derivative of sine is just cosine. The same thing here, derivative of cosine is negative sine. Derivative of sine is cosine. Then I have to find the magnitude of t prime. So to find the magnitude, we have to raise this to the power 2, raise this component to the power 2, and then raise this to the power 2. So we get 1 over square root of 2 to the power 2, which is going to be just 1/2. We have to raise 1 square root of 2 to the power 2, which is just going to be 1/2. 1 to the power 2 is 1 times 1. The square root of 2 times the square root of 2 is just 2. We also have to raise minus sine t minus cosine t to the power 2. So negative sine to the power 2 is sine squared. I have to multiply 2 by negative sine by negative cosine, which is going to be positive because it's going to be 2. Negative times negative is positive sine cosine. Minus cosine to the power 2 is also cosine square of t. But sine squared plus cosine squared, that's 2 plus 2 sine t cosine t. So when I raise the x component of t prime to the power 2, I just get 1/2 times that. So it's 1/2 times 2 plus 2 sine t cosine t. But also I could distribute this 1/2. 1/2 times 2 is 1. 1/2 times 2 is 1 sine t cosine t. So this is just going to be the square of the first component. So I raise 1 over square root of 2 to the power 2. Then I raise the parentheses to the power 2 minus sine t minus cosine t, which this is what I got. Then I distributed this 1/2 by both terms, and this is what we have. So I will end up with 1 plus sine t plus cosine t. The same thing is going to happen to this guy. 1 over square root of 2 gets raised to the power 2, gives me 1/2. And instead of minus sine minus cosine, I have minus sine plus cosine to the power 2. So minus sine to the power 2 is sine squared. 2 times negative sine times positive cosine, that's a minus. Then I have raised this to the power 2, I have cosine squared. I have sine squared plus cosine squared. That's going to give us 1. I don't know what I got. Why did I say we have a 2 here on the previous? So I'm sorry, I just want to go back to the previous calculation here because I don't know why I put a 2 here. That must have been a mistake. So let's track back my work. I apologize. I think I made a mistake here. So let's go back to this piece. So that gives us 1/2. Then I have minus sine of t minus cosine of t to the power 2. So it's going to give me sine squared. Negative times negative is positive. 2 times sine times cosine. Cosine to the power 2 is cosine squared. Then I add sine squared and cosine squared. That gives me 1. And then I have 2 sine t. So I will end up with 1/2. 1 plus 2 sine t cosine t, which is going to be 1/2 times 1 is 1/2. 1/2 times that is 1 sine t cosine t. So that's what we get for the first term. 1/2 plus 1 sine t cosine t. We also have to do the same thing to this guy here. So again, we have 1 over square root of 2 to the power 2, which is 1/2. Inside the parentheses, this is a positive. So minus sine to the power 2 is going to be sine squared of t. 2 times negative times positive makes that a negative, but again, 2 sine t cosine t. Cosine t to the power 2 is cosine squared. Sine squared plus cosine squared is 1. And instead of having a negative here, we are just going to have instead of being a positive, we are going to have a negative here. And again, this 1/2 gets distributed. And we end up with plus 1/2 minus 1 sine t cosine t under the radical. But they also cancel each other. 1/2 plus 1/2 is 1, and the square root of 1 is 1. So t prime is equal to 1, therefore is not going to have an impact. I divide this 1 by t prime, and it's just not going to change anything. So therefore, the normal vector, our normal vector n, is just going to be that. 1 over square root of 2 minus sine t minus cosine ti plus 1 over square root of 2 minus sine t plus cosine tj. That is the principal unit normal vector. Now that we have t prime and r prime, so we have t prime, its magnitude. Oops, I didn't mean to erase t prime. Okay, so let me just clean this up a little bit. Okay, so now that we have t prime and magnitude of t prime and magnitude of r prime, we have a magnitude for r prime as well. This is r prime's magnitude. Now we want to find kappa, which is the curvature. The curvature is the magnitude of t prime with respect to t divided by magnitude of r prime with respect to t, which is going to be, kappa is going to be 1 over magnitude of r prime, which is 8 e t square root of 2, or it's better to write it as 8 the square root of 2 e to the power t. And that is our kappa.